Hey guys, welcome back to another video. In this video, you will learn how to solve related rates problems. These problems are broken down into 6 simple steps right here that are listed. So for the first step, what you need to do is write what is given and determine the unknown. For your second step, you need to draw a diagram if needed. For your third step, you need to write a unifying equation. For your fourth step, you need to differentiate both sides with respect to time. For your fifth step, you need to substitute in values for all known quantities and rates. And for your sixth step, you need to solve for the remaining rate. These steps might seem confusing at first, but after we do a few practice problems, you'll see that they're quite easy and simple. So take a moment or two to copy these down. Alright guys, so for our first example problem, we have a puddle's radius is increasing at a rate of 2 millimeters per second. When the radius is 18 millimeters, how fast is the area of the puddle changing? So what we know is that we have a puddle. So I'm going to just draw a puddle. Let's draw right here. We have a puddle and the puddle's radius, so the radius is increasing outwards at a rate of 2 millimeters per second. So this is growing at 2 millimeters per second. When the radius is 18 millimeters, so when this line right here is 18, how fast is the area of the puddle changing? So let's follow our steps. So the first step is to write what is given. So what's given here is that the puddle's radius is increasing at a rate of 2 millimeters per second. So let's highlight that. And when the radius is 18, so radius is 18, how fast is the area of the puddle changing? So let's write down our givens first. So this might not make sense now, but the puddle's radius is increasing at a rate of 2 millimeters per second. So radius can be represented by r. So this might not make sense now, and it'll make sense later, but dr dt is equal to 2 millimeters per second. And then when the radius is 18, so when r equals 18 millimeters, how fast is the area of the puddle changing? So what we want to know here is when the radius is 18, how fast is the area of the puddle changing? Also known as what is the rate with respect to time of the puddle changing? So let's do that in green. This is what we want to know right here, this sentence right here. So let's write that in. dr dt equals, and we'll do a question mark. So the second step was to draw a picture, but we drew that right here already. So we want to know how fast the area of the puddle is changing. So in order to do our third step, which is write a unifying equation, we have to somehow incorporate all of this into our unifying equation. So since they're asking about the area, the unifying equation would just be the area formula for a circle, because a puddle is a circle. So area equals pi r squared. So now that we have the unifying equation, we can differentiate both sides with respect to time. So in order to do that, we just take the derivative with respect to time, and that would be dt. And this is where this comes into play afterwards. So we can take the derivative with respect to time. And actually for this one, I'm at dA up here. So we can take it with respect to time. So if we took it with respect to time, it would be dA dt is equal to pi, and then for r squared, that would be 2r, and now we have to take the derivative of dr dt, and it's right here in red, so let's write that in, dr dt. So right here, we're asked to find how fast is the area of the puddle changing. So we have to find this unknown, dA dt right here. And in order to do that, we have to substitute in. So in order to substitute in, we have to see what we can substitute. So we can see that we have to substitute r, which is 18 millimeters, and dr dt, which is 2 millimeters per second. So let's substitute that in. dA dt is equal to pi 2, and then we don't really need to write the units right now because we can solve them later. R is 18, and then dr dt is equal to 2 millimeters per second, like so. And if we solve this, we get that it's 72 pi. But then they're asking how fast is the area of the puddle changing, and in order to do that, we see that radius right here is millimeters, and we see that dr dt is multiplied by millimeters per second. So if we multiply these together, we get millimeters squared per second, which is the unit you would normally use for area. So this would be 72 pi millimeters squared per second. Alright, so for our second example problem here, we have that a 25-foot ladder slides down a wall at a rate of 1/2 feet per second. When the ladder is 3 feet away from the wall, how fast is the ladder moving away from the wall? So, in order to visualize this, it's essentially just a wall right here. There's a 25 feet ladder, and then the ladder is moving down the wall. So down the wall at a rate of 1/2 feet per second. And then they're asking when the ladder is 3 feet away from the wall. So when this is 3, how fast is the ladder moving away from the wall? So how fast is what is basically how fast this value right here is changing? So we can actually write this right here as, and I'll do it in the color we did before, 1/2 feet per second, 3 feet away from the wall, and there's a 25 feet ladder, and we want to know how fast is the ladder moving away from the wall. So we identified our givens and what we need to know, and then we drew a diagram. So now we have to find a unifying equation. So basically, any ladder problem is going to be the Pythagorean theorem, because y squared, so we can label this y squared plus x squared is always going to equal the hypotenuse, essentially. So let's write that in. Y squared plus x squared is going to equal the hypotenuse, and in this case the hypotenuse is 25 squared. And now we have to differentiate by time. So this would be 2y dy dt plus 2x, and then how fast is the ladder moving away from the wall is actually dx dt. And this is equal to 0 because the derivative of a constant is 0. So now we can substitute in dy dt, or how fast the ladder slides down the wall, is 1/2 feet per second. But then here we have to be careful because the ladder is moving down the wall, which means the value will actually decrease, or like the y value will decrease. So instead of 1/2 feet per second, it's actually going to be negative 1/2 feet per second. So let's substitute that in. 2y parentheses negative 1/2 feet per second plus, and 2x, we know that x is 3, so we can substitute that in. 3 and then dx dt. And this is equal to 0. So right here, we run into a bit of a problem because we don't know what y is. But then the thing is, we can figure out what y is because of the Pythagorean theorem. So in order to figure out what y is, we have to plug the values into the Pythagorean theorem. So this would be y squared plus 3 squared equals 25 squared. I'm just going to skip to the answer because you guys should know how to use the Pythagorean theorem. But it is y equals root 616. And then this right here can actually be rewritten as, or actually we'll just leave it as root 616 because that's a satisfactory enough answer for now. So if we leave it as root 616, we can input it in. So 2 root 616 negative 1/2 plus 6 and then dx dt. And right here, I'm actually going to simplify this real quick. So negative 1/2 times 2 is just negative 1. So this just goes to negative 616. And then plus 6, I'll bring it closer for you guys. Plus 6 dx dt like that. And this is equal to 0. So now all we need to do is bring 616 to this side. So we get dx dt is equal to root 616 over 6. And then this can actually be rewritten as root 154 over 3. And now we have to find our units for this. So if we wanted to find our units here, we see that how fast is the ladder moving away from the wall. And since the rate up here was written in feet per second, we can safely assume that this will also be written in feet per second, since a rate is how fast something is happening. So our unit would be feet per second. Feet per second. So guys, if this video helped you, please subscribe and like the video. If you want more calculus videos, please comment it with the topic you would like. And if this video helps you prepare for your test, please subscribe. Thank you. See y'all later.